Hi! Today, I'm here to discuss sample problems on integration involving trigonometric function. I know many of us are having difficulties in integrating, especially when trigonometric functions are involved. Oftentimes, we forget some basic rules when integrating, like improper use of integration formulas in general and giving the wrong derivative or integral of a function. These are the common mistakes we usually encounter. But hey, let me do my part by sharing my knowledge on how to integrate functions involving trigonometric function. First, let me review the integral of some trigonometric function. The integral of cosine u du is equal to sine u plus c. The integral of sine u du is equal to negative cosine u plus c. The integral of secant squared u du is equal to tangent u plus c. The integral of tangent u du is equal to negative natural log absolute value of cosine u plus c. The integral of secant u tangent u du is equal to secant u plus c. The integral of cosecant squared u du is equal to negative cotangent u plus c. The integral of cosecant u cotangent u du is equal to negative cosecant u plus c. The integral of cotangent u du is equal to the natural log the absolute value of sine u plus c. So those are integral of some trigonometric function. Now let's try to solve this one. Solve for the integral of secant x dx. First, let us multiply secant x by secant x plus tangent x over secant x plus tangent x. Basically, there is no difference since secant x plus tangent x over secant x plus tangent x is equal to 1. Distribute or multiply secant x to secant x plus tangent x. Now we have secant squared x plus secant x tangent x over secant x plus tangent x dx. Then let's determine u and du. Let secant x plus tangent x be our u. Then the derivative of secant x is equal to secant x tangent x plus the derivative of tangent x is equal to secant squared x dx. Then dx is equal to du over secant x tangent x plus secant squared x. Let's substitute dx in our function. Integral of secant x tangent x plus secant squared x over secant x plus tangent x times du over secant x tangent x plus secant squared x. We now cancel secant x tangent x plus secant squared x. We are left with integral of 1 over secant x plus tangent x du. As we mentioned earlier, our u is secant x plus tangent x, so we may rewrite it to integral of 1 over u du. What we have here now is a log rule formula, and since the integral of 1 over u is equal to natural log absolute value of u plus c, we simply substitute secant x plus tangent x to the variable u. Then our final answer is natural log absolute value of secant x plus tangent x plus c. This is our final answer. Same true when we solve for the integral of cosecant x dx. You may pause this video so that you can answer on your own. Multiply the integral of cosecant x to cosecant x minus tangent x over cosecant x minus tangent x dx. The result will be equal to cosecant squared x minus cosecant x tangent x over cosecant x minus tangent x dx. Then we find u. U will be equal to cosecant x minus tangent x, and its derivative will be negative cosecant x tangent x plus cosecant squared x dx. Dx will be equal to du over negative cosecant x tangent x plus cosecant squared x. We substitute dx to our function. The integral of cosecant squared x minus cosecant x tangent x over cosecant x minus tangent x times du over negative cosecant x tangent x plus cosecant squared x. We now cancel cosecant squared x minus cosecant x tangent x. We are left with integral of 1 over cosecant x minus tangent x du. We may rewrite it to 1 over u du, and it will be equal to natural log absolute value of u plus c. Then we substitute cosecant x minus tangent x to the variable u. Our final answer will be natural log absolute value of cosecant x minus tangent x plus c. This is our final answer. Here's another example. Solve for the integral of sine raised to 5x dx. First, let's expand the function so that it will be easier for us to integrate. We may rewrite it to the integral of sine squared x times sine squared x times sine x dx. Then we combine sine squared x. It will be now equal to the integral of sine squared x raised to 2 times sine x dx. Remember that we have a Pythagorean identity since sine squared x plus cosine squared x is equal to 1. We can rearrange this to sine squared x equal to 1 minus cosine squared x, so that we may use it in place to a sine squared x in our function. We'll write this as the integral 1 minus cosine squared x raised to 2 times sine x dx. Let us now determine our u and du. In finding u, we need to consider which function would be equal to our u. Our u will be equal to cosine x. Its derivative will be equal to negative sine x dx. And our dx will be equal to du over negative sine x. Let's substitute dx to our function. It will be now equal to 1 minus cosine squared x raised to 2 sine x times du over negative sine x. We can now cancel sine x. We have now negative integral of 1 minus cosine squared x raised to 2 du. We can rewrite this as negative integral of 1 minus u squared raised to 2 du. Then let's expand our function. It will be now equal to the integral of 1 minus 2u raised to 2 plus u raised to 4 du. After we integrate each one separately using the sum rule and the general power rule, we have now negative integral of 1 du minus integral of 2u squared du plus the integral of u raised to 4 du. Then it will be equal to u minus 2u raised to 3 over 3 plus u raised to 5 over 5 plus c. Simply substitute the cosine x to the variable u. It will be now equal to negative cosine x minus 2 cosine raised to 3x over 3 plus cosine raised to 5 x over 5 plus c. Our final answer will be equal to negative cosine x plus 2 over 3 cosine raised to 3x minus cosine raised to 5x over 5 plus c. And this is our final answer. So, I hope you learned something from this video. If you have any suggestions and feedback, feel free to comment it down.
If you like our video, please leave a thumbs up.
If you love our video, react hard!
If you feel happy after watching our video, just react ha ha!
If you are amazed by our video, react wow!
Thanks for